Hello.
Hey.
Hey, hello.
Hi, Maruti. Is that how you pronounce your name?
Yes.
Okay.
Yeah.
Okay. Do you mind switching on the video?
Yeah, I'm trying. Yeah.
Hey, where are you from?
Yeah. I'm New York.
New York?
Yeah.
Okay. What do you do? Do you want to give us some introduction?
Sure. I think hello everyone. Good evening, good afternoon, whatever, based on your time zone. Yep. My name is Maruti. You can call me. Yep. That's last name is Anamulapalli. Right now I'm present in New York. I work for JBNB, Jaros, Baum and Bolus Consulting Engineers as a senior engineer in energy modeling for the past 2.5 years. Previous that 1.5 year, I worked as an energy engineer on field. So I switched from field to like totally on conceptual and modeling side.
Right. How did you come to know about EPSI?
Like I, through JBNB, one of my associates, like who's my manager, has previously in IPSA. So he introduced me to IPSA. So then I looked into the committees and I found IPSI. Like that suits me because as a new to modeling, so I joined it.
All right. Have you been added to, like, have you applied to be a member?
Yeah, I was right member. Yeah.
All right. Awesome. Anyone else wants to introduce themselves to Maruti? While we are waiting for other people to hop in, and we are hoping people will.
I can go.
Yeah, someone go.
Hi, I'm Apurva. I'm based in San Francisco. I'm a building performance specialist at an integrated design firm called LPA, and I'm also the vice chair of EPSI. So welcome, Marti. We are really happy that you're here.
Thank you. Thank you.
I can go next if you can still hear me well.
Yes, we can hear you.
Okay, awesome. I'm having some terrible Wi-Fi issues, so I'm very frustrated, but never mind. I'm Nupur. I'm based in Chicago, and I work at Bauman Consulting as energy and commissioning engineer. I'm also part of EPSI organizing committee, and most of the time at my position, I'm doing building performance simulations, including energy modeling, daylighting simulation, and any sort of simulations. It is very nice to meet you, Maruti.
Yeah, nice to meet you too.
Rashmi?
Yeah, and I always go last because I don't want to interrupt anyone. But I can go next. I'm Rashmi Balika, and I work as a building performance consultant at Affiliated Engineers, AEI. Similar role to what Nupur just described, a lot of simulation analysis or data analysis. And yeah, I've been working there for almost 2 years now.
Great.
Nice to meet you.
Nice to meet you.
I can go next. Hi, hi everyone. Hi, Maruti. My name is Wei. I am the energy research engineer in Pacific Northwest National Lab. And I'm also the one of the organizing committee in EPSI. So I'm working in PNL as the most of my time is the software developer, as well as the I would say like a marketer that to try to connect with the consultants and the software vendors to connect with them and let them connect with them and provide the customer service for the tools that we're developing.
Got it. So if you work on PNL, so it's one of the 3 labs that you work on. Energy Plus, you guys work on Energy Plus development. If someone raise a request to add some equipments to Energy Plus, you guys do that one?
We do. So I'm not at the Energy Plus side. My I'm in charge of Open Studio standard package development. And also there are a couple of other standards and the tools development like ASHRAE standard 229 I'm in charge of the development of the standard 229 tools. Yeah.
Makes sense.
All right. So it's like my turn. I am Jayati. I am the chair of EPSI. I'm also a director for IBPSA-USA. So I am an architectural researcher at CoveTool. I've been working there for around more than a year now. And I do have a background in architecture, but I did my master's in high performance buildings from Georgia Tech. So yeah.
I have a meeting with Patrick tomorrow.
Oh, really?
Yeah, I have a bunch of people with Patrick, Peace, Daniel is not joining, William, Louis, a group of, I guess it's a load modeling tool team.
So, okay, so by the way, just to give some context, Patrick Pease is the director of mechanical engineering at CoveTool, where I work. And so what is the subject of the meeting? Are you guys looking at the tool or?
Yeah, I talked to Patrick. I actually talked to Daniel before, but Daniel referred me to Patrick Pease, not the Chopson. So Patrick Pease, and I had a conversation with him about that our latest ASHRAE, the ASHRAE Appendix G 2019 baseline auto generation tool, which I think there are a couple of companies, software vendors are pretty interested in this tool that we are developing. So Patrick was one of the vendor that had a plan to implement some baseline automation for Cove tool.
Okay.
So that's how we get connected and schedule this meeting tomorrow.
Nice. Good to know about it.
I appreciate you guys because I know Cove tool is a fast-growing software company, and we'd like to work with Cove tool for sure.
Yeah, I mean, okay. Has anyone ever heard of CoveTool before?
I think, yeah, we have used it previously. I think when I joined JVNB, we tried out CoTool and other tools, and we ended up with the design builder with Energy Plus finally.
Okay.
Yeah, we tried IES and we different, like every software out there, but finally landed up with the design builder.
How long? Oh, you use CoveTool?
Yeah.
Okay.
Not much. I haven't used much because I'm not doing the shoebox modeling and stuff a lot. But one of my colleagues is.
Okay, so Bauman Consulting is using CoveTool then. Yeah. Okay.
So what other
Great.
softwares do you use? Marty, what other softwares do you use?
So we use IES, we use Design Builder, we use Open Studio. It's based on project type, based on the budget issues, and based on the flexibility of time and everything, so that we decide what tool that we need to use. If it's a simple project, we end up with the eQuest sometimes. If it's like a pretty big, and if we need like a lot of data analysis inputs, CFD and everything, we try to do with the Design Builder and other stuff. Yeah, it's varies from project to project, but mostly 90%, 95% it's Design Builder itself, because of our projects like so complicated, it takes times, and simulation times too also. It's a heck of a time.
Have you guys, anybody used the Title 24 module in IES? And what are your thoughts about it?
No.
No.
Don't use IES at all, actually. Yeah. They don't even, I think my office doesn't even use Design Builder. I don't think anyone does. We just use Energy Plus. And we've recently started using or started trying to build our own Open Studio SDK.
Have your own tool, right? I know Sagar is developing some web-based platform.
Yeah, that's different from AI though. That's his own thing.
Oh, that's different from your. And I know Madison office was developing a web-based platform that they wanted to use for some projects.
The web-based platform is, I think the development is complete almost for loads modeling. So they're doing all their like internal tool
Test.
development because we have mechanical engineers in
Right.
a big mechanical engineering team.
Yeah.
So that's probably what you heard about.
Yeah.
But we're actually like in the the building performance team is much smaller, and we're
Okay.
trying to use the SDK, Open Studio SDK with Python integration to actually build out some energy modeling stuff for our own.
Oh yeah, right. I remember Yuan told me some of the workflow that you guys have. And who's the head of the sustainability?
So in our office, so the company-wide head is Paul Erickson, and our office department facilitator is David Conan Gillis.
Okay. I know there's another guy, but never mind. I know AEI had a lot of software developers. I'm pretty close with.
Are you talking about James McNeil by any chance?
Yeah, he used to be in PNL. He left in February. So we worked directly on a few projects for just a few months. Yeah, it's pretty awesome guy.
Yeah, I didn't actually get to work with him, but I've heard a lot about him from David. David used to work with him a lot.
Right.
Yeah, and RF maybe, like I'm trying to figure out who you're talking about. Maybe RF Hanif.
No, yeah, I know like one or two guys probably from AEI, but yeah.
Okay.
Yeah.
Well, now you know me, so.
Yeah, good to know people. Yeah.
So through that, like I just had a question. What are your expectations from EPSI? Like when you're joining the group, what do you think? And I would want to start with Maruti first.
I just want to make connections and know what is going out in the market and see what people are up to, because building simulation, because I'm new to this energy modeling. Previously, I worked on field, I know on commissioning side and those type designing side, but I switched to energy modeling. So I just want to make connections, see how the market is moving on. It's like more tool development or trying to create new equipments or making like cutting edge technologies from the design perspective. So I just want to explore those options because JBNB is more on cutting edge technologies design perspective, not on tool developments or not just using tools as existing or try to, if the tool is not efficient to as our expectations, we try to get some answers from experts so that we can able to operate those things. But our focus is on more designing side. So I just want to explore what is outside other side of the stuff.
So you want to know, yeah, go for it.
So I think you may have mentioned this before, but it's escaping me right now. What types of projects does your company work on? Like which typologies?
We mostly, if you've seen 30% of the New York skyscrapers is under our control. So it's like any big projects that you see from World Trade Center, any to JP Morgan new headquarters, that we touch everything. So
That's
it's like
pretty awesome.
So it's all big buildings. Yeah.
So it's all, do you find that design builder is sufficient for that scale of building?
It's efficient, but not as our expectations. Sometimes because every energy modeling tool had their pros and cons. Sometimes so that we try to post-process everything. So some of the technologies that we are working on designing side that doesn't even exist in any energy model tool. So we try to do our own modeling software. Like we are trying to come up with not software, like just like tool for calculations, how the behavior works. Try to get the information from the existing building so that how the new building will replicate. So those things, yeah, but mostly on like commercial offices, life sciences, laboratories, and those stuff.
Yeah, I think those limitations are kind of like why our company stopped using anything. Like they used to use eQuest and stuff like that, and it's just not sufficient. And Energy Plus just really opens up opportunities for like custom configurations.
Yeah, we hope now Python is coming on, so that might help us in modeling somewhere. Yeah.
So is
how
it on?
Do you develop such
go for it.
For custom calculation?
Sorry?
How do you develop such tools for custom calculation?
It's an Excel, but we do some mathematics. Those things, people are there like, yeah, we know behavior so that it's, yeah, our expectations, like if someone designed something, if you go and search something on our website, which is we called our group as Deep Carbon Reduction. If you search a website, deepcarbonreduction.com, you will have a tab on that one as knowledge. You can see what are the technologies that we are working on right now. It's like called high seating, using high seating for the recover the heat from the building, existing in the building itself, so that to heat the perimeter spaces, those type. So we use water source heat pumps, some stuff. So we know the equipment operation, how it behave, and we use those calculations and to recover the heat and transfer it to other spaces within the building itself. So because mostly New York City is more stringent on climate like those stuff, local 97, which is going very big right now. We are on the forefront on that one because our partner is like a advisory board for the local 97. He's the committee for the mayor and those stuff. He's on chair of the Urban Green Council, if you might heard of that one. So we are pretty on designing side, try to do more decarbonization, but tool is like one of the medium that we can show the savings, how our like design is much better than other designs. So
do you want to drop a link? You were talking
sure.
about the site.
Yeah.
Like that will actually help us look at it.
Sure. It's a
Do
we
you
just
all,
made.
yeah, do you all just do energy analysis for the buildings, or do you also take into account other aspects like cost and, you know, maybe daylighting or something like that? Or is it
Yeah,
focused
it's like
strictly on energy?
because most of our market is on Northeast, like Boston, Philadelphia, and New York, mostly on energy, but we used to do daylighting, but more like our associates and managers have previously done CFD and daylighting. But as of now, our more like projects is not demanding of those stuff at present.
Anyone else? Do you all do anything apart from energy? Like carbon is a big thing, you know. Like what tool do you use for carbon?
I actually do a lot of energy audits. So for that, we usually, like in the report, we give carbon emission of the existing building, and we use this tool for by EPA to just calculate the carbon emission based on your energy usage. It's a very simple.
Oh yeah. Oh yeah, the tool that actually converts it to various things like trees
Yes.
and then, you know,
Yes.
okay.
Is
The
that
greenhouse
IQ or
gas
something?
equivalencies calculator.
Yes.
I love that thing.
It's very easy and quick. For energy audit projects, we don't have a lot of budget to spend on, so we just do use simple things.
What about, so are you guys more on an analyst type of role? Really, I know you're in research, but for the others, are you more as an analyst, or are you also focused on consulting and presenting and visualization?
I'm more on consulting.
Right.
Mostly on consulting.
So what tools are you seeing out there that you're mostly using for consulting work or data communication?
So far we have been using Excel for the presentation and stuff, but we use Cinevision and Grafana platform for the data visualization, but that is used for the commissioning and monitoring based commissioning part. But we really want to develop some tools for the energy modeling, data communication, so that we can convey the results. I actually saw AEI's Python Power BI platform, and it was really nice. For one of
Which
the
one?
So for one of the
Which one?
projects,
Okay, that's a difficult question, Rashmi.
no, I might can explain.
Yeah, because I think it's more like we have several Power BIs out there because we use them for presentation. It's not like we have one website where it's not
I
a
know.
tool, it's just a web link. So
I have seen two. One of them was for mechanical systems, like to select better mechanical options, and another one was to present energy modeling
Okay.
results.
So how is, like, I just know Power BI as Microsoft tool.
It's
Are
an
you guys?
yeah, it's an Excel one extension, just like as Tableau came up with the data visualization, so Microsoft came up as a competitor with the Power BI.
Hi, everyone.
Yeah.
Okay. Is that the YouTube video that you said.
Yeah.
No, actually I just opened it. It said the electrifying buildings with ice or something like that.
Yeah.
Do you want to share takeaways? If you've seen that, like you want to introduce us to the video, Maruti?
Sure. That is one of the new technologies that our company is working on as New York City, mostly winter conditions. Most of the time is like more cooling, heating demanded city, and Northeast entirely Philadelphia and Boston. Most of the clients is also located in that one. So we're coming up with that type of technology where that you can use your existing loads where instead of rejecting the heat rejection through the cooling towers, that you can use that rejected load and use to heat your perimeter system so that you can reduce your sizing of air source heat pumps and water source heat pumps so that you can't waste a lot of real estate, so that it will be like a cost efficient for the real estate developers and everything, so that and they can go with the SOC heat pumps as the size of the SOC heat pumps and water source heat pumps will be reduced, and they can't even opt for the boilers and other district steams, which is like more carbon intense. So that this is the way that we try to decarbonize one of the technologies trying to.
Yeah. It sounds kind of conceptually similar to like a heat recovery chiller with thermal like ice storage.
Yeah, ice storage, but the condenser heat recovery will be also processed, but it mostly on the cyclical loads of the existing building itself on the load. Yeah.
Okay.
But we mostly play with the plug loads and other stuff, based on the conditions and everything in the building.
How do you project plug loads? Like how do you collect data from? I think you mentioned you collect data from similar buildings.
Yeah. For the past 1 year, we are trying to do research on that one. We are trying to get information from our existing clients. Our majority of existing clients is New York University. They had office spaces, they had classrooms, and they had lab facilities, and we had kept everything. So as we designed, we had the data information so that we can use their existing information and conceptualize and use for the clients. We will get the submitter information and what are the night loads, day loads, everything during how the building is behaving, so that we can use similar type for the other buildings.
That's really nice, because every time I issue a like modeling analysis report, my biggest disclaimer is that sensitive to equipment power density.
Yeah, that's
it's great that you have some data to calibrate that behavior.
Yeah, it's like past 1 year we are struggling with that one, because last 2 years, 1.5 years, when we try to do concept design, we just assume something. People come with the HVAC engineers, assume something. Yeah, we can't assume something which we oversize your equipment that can't even fit in systems. So we're trying to do research with our existing clients, play with them so that we can able to get the data and we can reuse for other stuff.
Oh, so we actually collected all that data, like from all the projects that Arup did. So whatever from past experience, they collected like all the data about the system types, and then that's what actually Cove started using. So all the data, because there's no data in the standards for this thing, right?
Yeah. Previously, some people will use CBEX data.
Yeah.
So, but it's not that efficient one.
Because it's not granular enough. It's just like,
because each building is unique and their schedules also varies.
How detailed you typically go? Like, is it a template data is enough that you take it from CBEX or from prototype model is enough, or you have to for lighting, you have to go down to the blasters each lighting fixtures to calculate the voltage?
That will come in the last phase, CD phase. Definitely, that will go as deep as much. Yeah,
right.
We even count the fixture. Yeah, we will get the consultants and we'll get the fixtures and everything. We just want to know the watts. If they are going for well certification and lead certification, we just do every detailed motion of modeling that we want to.
I'm just wondering, like at different stage, the need for those kind of data or the level of details for those kind of data is different. Right?
Yeah, because we go detailed, because that will definitely change the decision making of the client at the at the end phase. Definitely they will go with definitely they will impact the decisions making will be impacted.
Veli, is your like, how is your day? Like, what is your day like? How do you, like, what all is included? Is it all research? Do you work on standards or projects with DOE? What is included in your?
It changes every time, like usually, because yeah, mostly if we are packed up with the projects modeling side, we packed up with that one. Sometimes our days will be totally with meeting sets. We can't even touch the tool sometimes. Totally like going with the clients, understanding what they want, exactly what they want to do in their building and those stuff. And some people only dedicated to do modeling, they will only do modeling, and some people will handle the standards. Some people with the handle the DOB, Department of Buildings, and the others with the government affairs. They will be, yeah. So everyone had their own role, but some people will be run around different all those sectors.
Willie, what about you?
For codes program, the number is derived from like literature reviews and the feedback from the utility providers. We not basically weighted and normalized those data. But for some of the equipment, we tend to separate them, like motors and elevators. Those will be separated out from the electrical equipment. I don't really touch that part a lot, but there's different levels of, as far as I know, there are different levels of data collection process. So we have a SS Score tool, which I'm also part of the SS Score tool team. The way how they collect it is to ask the users to type in the number of fixtures, right? And specify what type of lightings that is installed in the building. So from the fixtures, from the type of the lighting, the software calculates the voltage of the lighting. There are tools that basically does the more like generic template approach where it takes the data from some public numbers, prototype models, for example. That's very typical. And that's like, you know, that's how we see the data. But personally, I like the way how we see as uncertainty variables. We are internally, we are working on collecting a database where there's each variable has uncertainty values as well as the distribution types. In that way, we think it's probably going to be useful when we do uncertainty analysis to say, like, you know, you have this design and this is a risk associated with the number, with the annual energy consumption. Like, you know, simulation just give you a number of the UI, but there is a subject to, like, at different stage, at the early stage, you're subject to 20%. That we typically say 20% plus and minus, but it's basically we collected those data to calculate and quantify the uncertainties. It's not a 20%. It could be like, you know, 10% or 15%, something like that. Yeah.
Yeah, I was more interested in the job profile. Like for me, it's suddenly like going back to Rashmi's question, like for me, the job would have been a consultant after my degree. But then I went into Cove Tool where we are developing the tools. So my day is like, I research about various things, and because I have to introduce a feature to them. So if I am going to work on embodied carbon, I need to know everything, like all the EPDs, what are the other tools doing, like wherever I get the information from. So I need to know more than other people who are like doing it for more than 10 years. And then only I can develop a tool or give them a feature out. So so it turned into research more and more about like talking to architects and engineers rather than getting a building, running simulation on that, and then giving a feedback. Although I always imagine if I would like that more than this. So that's why I wanted to know different job roles that you guys are doing. Like, so if anyone else also.
In my previous job, I was doing more of a very focused energy analyst, doing all this building performance simulations, lead, Title 24, savings by design, all of the California centric stuff. And now I'm at a position where this is an integrated design firm where the architects want to know how should their design be better informed in terms of performance, energy, carbon, daylighting. And in my previous job, we would take like longer. I would use eQuest, IES, and just do, modeling for 2 weeks and then present results. And now these folks want results in like 2 days. They're waiting on selecting something. They're waiting on selecting between option one and option two. And the tools that I've been using here are also very different than what I would use previously. So it's technically the same job profile, but in terms of what I do in my day, it's very different.
So
And
from were you doing more of compliance earlier?
not really, I was doing everything else also, but here, uh, sometimes it's about convincing even this team works more in K-12. So it's about convincing the school district to think about net zero, to think about putting in PV. So even before you have really secured the project, you need to show them that, hey, our sustainability goals are going net zero, and this is how much money you need to allot to your budget to be net zero. And net zero is really important. So this is my presentation for it. And
Okay.
everybody who came to A10 already knew that they wanted to be net zero. They wanted to have those really high sustainability goals. So I never had to go to anybody and convince them, why don't you do this? This is really good for you.
Oh,
So it's
so
an interesting change of pace.
okay.
Yeah, that's a great type of role, I would say,
Yeah,
because you don't have to spend time convincing people that it's worth it, or like, um, I mean, I think AEI gets a lot of like higher ed projects. So higher ed wants to be sustainable anyway for political reasons. So it's not that much of an issue, but there's always these like some locations where you get projects in states which have just regulations you have to fight against. So if you're like in a company like A10 in a progressive state with like less negative like political implications, I think that sounds really positive, and you must love your job.
Oh,
Just,
God.
I think what you are doing, Apurva, now is more impactful than like the consultants do, because like for a lot of projects, we are brought in at the very end of the project for the lead documentation and submission part. And sometimes I feel like it doesn't add value, right? You can't do much to improve the design. But there are some projects, like some people who would involve consultants from the beginning of the
Oh,
design.
oh God,
So
we should invite you for the Cove Tool speech, because we have been convincing people to do it from the early stage analysis. Like, just start, use any tool. We don't care if you're using our tool or not. Just
yeah, even
like
lead, like
apply it.
actually,
start
like I
thinking
don't know
about
how
that.
lead projects even end up with that, because lead has a prerequisite for integrative process. So most of our projects at least don't have that issue where like they come to us in the end. And I don't think I've been on one of those yet. Like usually we're engaged from the SD. So this is like, if you're doing a lead project, you're somehow like taking that credit. I don't know how that works.
I think for most of the lead project, like mechanical team or architectural team have that in-house like modeling team, or maybe like they can just do it by themselves, but like the initial analysis, and then we are in the picture. But I mean,
Yeah,
So
I see what you mean.
yeah, at least they should do it. Like the architects,
exactly.
while they are making the
Mhm.
decisions, they should run the analysis on their own and then see like what kind of decisions they are making. Because once they set the orientation of the building and everything, they have decided that, okay, this is my design, this is the system I'm going to go with. what else can you suggest them to do? Like provide a
Yeah.
louver? Is that what consultants are for? To
Yeah.
provide that kind of, feedback? No. And I always imagine, like I have talked to so many people, like from my field, high performance buildings, and they always say that it kind of becomes very difficult to tell the architects what to do, because when you give them the feedback, they will just keep it aside and will do what they want to do.
That's the issue, because the role of the architect in a building construction project is that of a leader, and everyone else is contracted to them most of the time, unless it's an industrial project. So the challenge is sometimes you really don't agree with them, but ultimately you have none of the control. All you can do is try to convince them, and that can get Maruti is like vigorously agreeing with me.
because they worry about aesthetics. They don't care about what going in the building mostly, because there is a project that architect was fired, but we haven't got fired. A project was handed to the architect. They did the concept design, they did SD phase, and they fired and they hired new architect. But we stayed as an engineers because they worry about the aesthetics and everything, but they don't care about what mechanical engineers want to do from the performance perspective.
When I was an architecture student,
Yeah.
when I was an architecture student, we used to hear about this like someone's thesis project. It was like one of those stories that everyone told. Someone who did a really great design for a museum thesis project, and then failed their exam because they forgot to put a staircase in the museum. So it had like it's like one of those like stories that everyone tells first years in college so that they never forget to put a staircase in their building.
Oh, I still hear all of those things. Like we had a demo, like we give demos for the tool, and then we support them, like how to incorporate in the workflow. So they were architects and we showed them the tool, and then they were like, oh, you should show it to the engineers, they have problems with us. So we were like, okay, we have load modeling as well for like sizing, system sizing and stuff. We will show that to them as well. We jumped on the call with the engineers. We were showing them the tool, and they were like, who told you we need it? It's like your architects told that you have problems coordinating with each other. So this is a good tool to invite everyone to a single project and run all the analysis together. They were like, that's not the issue. The issue is architects make changes to their design and they don't tell us. So how do we make the updates to our results? They're not telling us on time. I was like,
They
okay.
didn't even mention in the meeting, like a call-up meeting, they will send a new updated set. Suddenly, okay, you see the flow change. Okay, God damn it.
That's
that I need to do again.
Yeah, I mean that's a very interesting, because one of my job, like I had a multiple job in the past. I worked in the from 2018 to 2020. I worked in a company where we are integrated project delivery company. Like we does like at the client side, we assemble the team for the development for small single family house to 3-story to 4-story apartments. And the interesting thing that I see is architecture takes the lead, but the only person in the team that can say no to the architect is a structural engineer.
Yes.
They can say no to architect, and the architect has to follow the structural engineer.
Because the building will fall.
Exactly. The other for mechanical engineer, what architects need to know is how much space you need for your equipment. That's the only thing architects will consider. That's the only request the architect will consider from the mechanical engineer.
Even then, there's going to be some bargaining there. Like if a civil engineer says, "Hey, there needs to be a column here," they'll probably say, "Oh, okay, let's see what we can." But if you say, "Hey, I need like X square foot more for my chiller," they'll be like, can't you find a smaller chiller? Can't we put it in this corner right here where it's impossible to fit it?
Not even
Under
chiller,
the
yeah.
staircase, like in this attic.
It's happening like all the time. So what's happening, like if we think about like collaboration, it's really push the edge of the simulation towards building information modeling, where that a lot of things that happens at that end is design collaboration in terms of the CAD changes, the Revit changes, the construction documents, construction contracts, where have to make sure they do the proper job, and someone does the quality assurance and someone pays for the job. And a lot of things going on there. And having energy modeling is in fact not saying like COVO tool, because you guys are like a fast simulation tool, right? But doing like a lead certification modeling, that's like a full-blown modeling service, is actually something that will drag the project progress, especially drag the process for a permit application. So that's why, like, as a building owner, it's typically very, very difficult to convince them, say like, hey, we need to do energy simulation. We need to do modeling, because whenever you start modeling, you start giving suggestions. Also depends on the stage of the design, right? That's why that's another reason why we wanted to push the modeling towards the early design decision, because at the later design decision, you really can't change anything.
I think there's that graph that everyone
Typically,
uses.
like I understand. I worked on site. Like I literally put up the 2x4 there, so I know like once you have a 2x4 there, you can really increase your insulation in the wall. And whenever the energy modelings gave like, you have to put an R25, R30. I don't have the space to put it. Literally, I don't have the space. And what I can do is put in the exterior insulation to boost up the insulation. But that comes a lot of issue. Water issue. That's the first thing. Like literally, that's the first thing everyone should think about it. Not the energy, not the air. It's the water. So water comes first. Air, like once you have the thickness of once you add a thickness of the exterior wall, you also need to dealing with the local jurisdictions to justify your FAR, so that you don't take too much space in your lot. Like a lot of things that actually happens. So I would say like energy modeling, it has to start with at the early stage, then you gain the authority in the team to say that you wanted to do this, wanted to do that. But when typically what's happening is energy modeling happens at the later stage, where you literally have nothing to say, but because like whatever you say, it's there already. It's in the planning permit there. You can't change the exterior wall thickness. You can't change the basement. You can't change the roof. You cannot change a lot of things.
Yeah.
Yeah.
Rashmi, were you talking about the McLeamy curve?
I don't know what it's called. I just remember it being used in a lot of like class presentations where you have like your x-axis is time. Yeah.
Right.
Can you share a link on that?
Yeah.
Or maybe I can Google it.
Yeah, I just wrote this because we keep on presenting this. It actually means that in pre-design, if you make some changes, it's easier, like less effort and less time. But as you move up, like the cost of the design changes, you have to like put in more time and then more effort to change anything.
So that's a very interesting story that I had with one project, right? At the design phase, we actually designed it according to the basically there's no like a simulation running, so we designed a 2x4 stud that's basically can host about like R19, and then the energy simulation assumes assume the R value energy. Of course, it happened at later stage after all the design is approved. Then the energy simulation comes out, and the insulation requirement is 2025. And that's in California. So Title 24 is mandatory. So we have to comply with Title 24. And the worst thing is the 2x4 is already on the site. There already, like you see the skeleton of the house there. So what comes out like at the beginning, if we fix that issue at the beginning, it's literally no cost because architects can just change it. That's like included in the one revision, right? So they can change it, but that happens on site. And in the end, it's a small project, so we paid about like $2 per square foot to fix everything, which like you can imagine how much cost it involved to fix the issue, to fix the problem that at the site.
I feel like I have observed that a lot of higher educational or like laboratory building or hospital buildings, like for those buildings, energy consultants are involved earlier in the design, like from the beginning. But for a lot of residential and like low budget project, they just don't have the room for.
Right. So I think you are hitting to a very critical point, which is whether it's worth to do it or not, because hospital, it's a big investment. You're talking about $10 million or $20 million investment, where energy simulation for those kind of services about like $50,000-$60,000 or something. That's a very small margin of the total project budget, where the single family house that you are looking at $300,000 development. Like small commercial buildings, less than 50 square foot commercial buildings, you're basically looking at $1 million development, where energy simulation can literally takes 20 to 30K for that.
I think for this residential market, what really needs to happen is we need to have good quality. Like there should be, I think some places already have this. There should be some incentives by the government to basically meter your single family house and sub-meter it. And then once you collect that data for enough houses, you can just provide like sensitivity-based recommendations. Like you can have all your insulation or envelope parameters as like independent variables, and you can predict what your outcome will be, so that you can provide like a recommendation tool to them without them having to hire some like an expert energy modeler. I think that's the needed thing in the industry for that sector.
I mean, like,
I think it's already there for such as like energy audits. Sorry about that.
Yeah, but they're like so like non-standardized and like not sub-metered, that it's hard to actually do any sort of like data-driven learning on them. And the cleaning involved is something that, I mean, I can only see volunteers or research organizations putting it together. Research organizations need that to be funded. Volunteers need it to be at least slightly easy. I feel like professionals don't have time to sit around and clean data the way that it needs to be cleaned, the way the audits are performed for residential. It's just too much randomness.
Right. I mean, I'm 100% agree this. Yeah.
Let's shift to a little less technical part. What do you guys think about your jobs? Like, do you feel ever unappreciated or insecure in your jobs? And then how do you deal with that? Like, do you think you need a promotion, or do you need to be paid more in your job?
I would say everyone would like to be paid more in the AEC industry. At least I would, given, I guess it's not as technically complex, but there's a lot of like deliverables and there's a lot of work that goes into it. And I've just seen a lot of other like engineering industries where people work maybe equivalent or in slightly lower pressure. I'm not talking about like tech where the salaries are insanely high. It's even other core engineering just pays better than anything AC related. And AC has like, I don't know, the worst type of pay from what I've seen in engineering from like just looking at Glassdoor. So I personally wish that we were more in, like, I don't want to be a millionaire, but maybe like AEC needs to do better.
I feel like when I look at Glassdoor, the salaries are like way higher than what I usually heard from people. Do you feel the
Yeah,
same?
yeah. I mean, we all know that's a fact that AEC salaries are low, but like let's go more local. Like, has that ever been the case that you are working more than your colleague and they have become the team lead, and you think that you deserve to be promoted or appreciated for that matter, and no one is providing that kind of motivation? Like, how are your senior engineers or senior bosses working with you guys?
I honestly never felt like that. I always felt like someone is there to like support and appreciate. Maybe I work for a small firm that's like we always push each other up.
I thought Bowman is a pretty like medium-sized company, not like a giant like a WSP
Yeah.
or AEI. Yeah.
So
So
how many employees are there in Bauman? Like,
now it's 30.
okay.
We had a lot of people this year.
Yeah.
So
Yep.
yeah, well,
You have a
yeah,
lot
You
of
mean 30? You mean 30 total or?
total, yes.
Yeah.
Like
Oh, really?
Chicago team is 7 people.
right.
I pictured Bauman as a much bigger company for some
Okay,
reason.
same.
They have a
I
lot
thought
of
it was like
external.
200 or something.
Whaley knows everyone in Bowman Consulting.
I know. Yeah, I know Olive.
Yeah.
He's a great guy. Yeah, he knows.
Even you know Ajit, right?
I know Ajit.
He is my direct manager.
Yeah.
So
Yeah. Yeah.
he is amazing person too.
Yeah, we are pretty close. And he's very good. He's very good.
Yeah.
Bailey's
So I feel
contacting
like
everyone from our companies, like whoever he meets in EPSI, he will just get in contact with them.
I think the reason
Yeah.
is Build Sim Hub, right? The tool you developed.
Yeah.
Bailey?
When I was working with Busing, I literally contact a lot of people at that
Yeah.
time. Yeah.
We were using that tool and it was amazing.
Yeah.
What
I think mainly for a project for Canada. Yeah, that was requires some mass simulation to. Yeah.
More
That-
for IMP
Right.
projects.
Right. That's right.
what does that tool do?
You
The
mean the
one.
tool, the project?
She mentioned the tool, right? I didn't listen, like I didn't
Build
understand the
Sim Hub?
name.
Yeah, it's called Busing Cloud, where we were working on a cloud-based simulation infrastructure specifically for Energy Plus at that time. So it's as easy as you push your Energy Plus model to the cloud server, and the cloud will run the simulation.
Oh,
Yeah, that's pretty much it. And we basically, on top of that, we add a little bit of functions like adding some measures, like add the controls, change the HVAC systems, and also provide some visualization options. Yeah, so that was the idea. So that leads me to Saga Rao from AAI and also in Bowman, I talked to Oliver and Ajit for sure, like a couple of people there, here and there.
I think it's a fun story that Whaley and I think one of your colleagues, you had come when I was doing my master's at CMU, Professor
Okay.
Omar had invited you, and we
yes.
all got like free licenses for like one project and X number of cloud hours to like try to fix our models.
Yes. Yeah, glad you still remember. But yeah, it's I mean, since the COVID, sadly, we didn't have enough cash to maintain the service, so we closed down as soon as COVID happened. Yeah.
oh,
Yeah.
Like I have a question.
Yeah. Yeah, go
I have a
ahead.
question. How your workload will be like? How many hours that you guys spend? Like my only complaint is like we had a ton of workload and hours like timesheets like skyrocketed. Sometimes it's like 12 hours, 13 hours, 14 hours. There was a
oh,
project that for 2 weeks we spent around 110 hours for 2 weeks for
oh
timesheet.
God. I'm just thankful for that because my timings are fixed. So 8:30 a.m. to 5:30 p.m. After 5:30 PM, nobody can ask me to work, not even reply to an email.
Yeah,
So they're
it's
like, just have your work-life balance,
yeah,
please. No work on
yeah.
Saturday, Sunday.
It's not just
Oh.
me. My teammates also will be on live everywhere. Everyone will be live because their workload will also, because we
I think
just
it's,
start, our energy modeling started only from 2018 as specific group, the deep carbon, and we're just building up. My complaint is they hire very slowly, but they hire very friendly people. That's a good thing on the back, good thing. But the bad thing is they hire very slowly because they need to find a person who is more friendly to other person who already in the firm. So they try to search a good person and just interview 2-3 times. If he know he's friendly, then only they hire. Because most of the people will stick with JBNB. Like we had an old person who stick with the firm for 55 years.
55?
Yeah,
That's
55 years.
Entire life?
Yeah,
we have some people like that too here in AEI Madison. Design engineers with like invaluable amount of knowledge just sticking around the
Yeah.
company and like sharing it. Even after they retire, they come back and
yeah.
I
It's like
feel
Cannot
like
leave the
work,
company.
right? I think 50 plus hours in a week has only happened to me like once or twice in the 2 years. I think up to like 45 is pretty more frequent, and 40 is like most frequent. So
oh,
for me, it's like, it's not a complaint because occasionally it does happen what you're saying, where the workload is crazy, and I think it's going to happen again this summer, but we're getting an intern, so hopefully not. But it's occasional, and most of the time, like it's unavoidable because coordination is so slow. Like, like it always happens that you know what you need to do, but as the analyst, you have to wait for everyone else to sort their stuff out so that you can finalize let's say it's a lead model for this time or lead documentation. All the designers need to sort their stuff out, and they have so much going on that there's periods for me when I have like barely anything to do. That's when I develop my tools so that I can like do it faster when they all get back to me at the same time. And then that's a really busy week. So I
Yeah.
think it comes in waves, is how I see it.
but
Oh.
I was like drastically reduced from like ton of hours to medium, then to regular 40 hours, 45, 50 hours, because we are early phase of the group that we don't know how many hours for the project budget will be. We know that, okay, if you negative on the budget, that's okay. But we had the project, we will, as a lesson learned, we will record the hours and everything. If you work 50 extra hours, just put it on. That's okay. If we lose on, we will cover on the HVAC side, designing side. If our energy modeling is not profitable, that's okay. We can use for the next project as a lesson learned so that we can have higher budget for the proposal we'll send, and we will ask for the extra time. That, like, I experienced on one time sheet that we kept 60 hours, 65, 75 to like reduce to 50, 55. Now it's like, okay, coming back to 45, 40, where right now. Like,
So they're
yeah,
just
when I
allocating you better now.
yeah, but sometimes, yeah, clients come sign, I just need in 1 week. Dude, you came up with some difficult project and you need 3 options, and in 1 week that not going to happen. And
I guess
architects don't even answer.
Yeah, you just need like whoever is marketing for you to say no, basically.
Yeah.
Or to, which I guess not everyone marketing for you may be saying no.
Yeah.
It sounds like.
That's the liberty that we get. Like, there are no clients. You're like, okay, push the feature ahead if you cannot complete it in time. But we did have lead documentation projects that they were doing from their previous consulting firm that they had. So those are still continuing because the building is already up. Like, it has been constructed now, and lead documentation is still not complete because they are not responding back in time, or they are not paying the receipt, like the money that we need to document it for. So they are waiting sometimes for the landscape architect, sometimes for the engineers, and so on. So
God, it's never
That's the
ending.
consulting world.
Good thing is, like, we don't have specific energy modeling project as a client, like exterior person. Our client is our HVAC team. That's it.
yeah.
we need to deal with our HVAC team. They're designing it. Our client is there. They deal with the client architects. They mess up with them. Okay. You need answers. Okay, I will give you this time. Right? That's it.
The good thing for us is that, like, if I'm spending like 50 hours this week, then I can work 10 hours less in the next few weeks if I want.
Kind of flex out the time.
Yeah, yeah.
Nice.
We
Most of the time,
kind of
if-
have that, but not to a large extent. Like I feel like you still need to do almost 40, but if you worked really hard the previous week, no one's going to bat an eye.
Yeah.
You can probably move some hours over into like the next time sheet, and about the work culture thing. My team I love my team. I don't want to leave my team until I have to move, because I've been being trained. So I came into AI with like zero knowledge of mechanical systems, and I can like comfortably talk about them now and like not feel like an idiot. So I feel like they've really taught me a lot. And yeah, I never feel like I'm like underappreciated or like someone is unfairly getting a promotion. That just doesn't happen.
That's what I was going to ask. Like, you had an architectural background, right, Rashmi? And like you did a degree, but degree is like a certain thing. Like it cannot teach you everything, especially the mechanical stuff, because they do not get into much details. Although I'm not sure how much detail you went into. But now you talk like you are like a mechanical engineer to like a great level, to a certain level. I don't know what mechanical engineers would say to that, but I think
would say
so.
I'm not quite there yet, but I can. So I don't understand everything about it, but because I work only, so I'm the only architect in my team basically, and we're not all mechanics. Like Paul Erickson, who is our lead, is not a mechanical engineer, but there are no other architects right now, and basically there's a lot of collaboration, and we have a really large mechanical design team who we collaborate with a lot in early stages. So whenever I'm on a project, like I have the opportunity to talk to all these mechanical engineers, and they are very open to answering questions. So I just ask, hey, like, what do you mean by this? And they just explain it. And then I first joined AEI like, as an intern 3 years ago. So it's enough time to catch up on, like at least being able to go through a conversation. I can't do any mechanical design. I would never call myself a mechanical engineer, but I can like get through a conversation with them without like feeling like I can't contribute to it.
Yeah.
I think most of the consulting firms had their internal classes, universities type. They will take classes for the all new highs because they don't expect anything from new highs. All they just want is people to work on, but they will teach from scratch. We had HVAC 101. They teach what is load exactly, what is BTU, from to all the way to all the
Oh my
company,
God.
like 400, 500 classes on each sector.
Oh,
Like,
I don't think we have that, but I feel like we need to, because not AEI specifically, I think all companies should, because the number of times I hear people calling BTU load is just like when, because when people say how many BTUs is your load, it just like makes me cringe because it's the wrong unit. And then it's like, like I've actually been provided data by facilities engineers where they're talking about kilowatt, like gallons of water per ton of load, which like, I don't know, it's just per ton hour of load or something. Like there was a wrong unit, and it's like I'm going to use this data, but I don't know what you mean anymore because it's like, yeah, stuff like that. So it's really good to hear that your company does like extensive training on that, because there's so many misnomers in like imperial system. Is like MBH. What is MBH? It really like for a year I had no idea what MBH meant, and I was so scared to like ask anyone. So I used to Google it every time because it doesn't make any sense. It looks like million, but it's per hour, and it's M means 1,000. Like that. That's just the worst unit I've ever.
Those conversions were so crazy for a while. I used to get confused all the time, and I was using eQuest in my initial days, and eQuest would produce something else which meant different in the real world. And
I think the most struggle time that I had was when I just started my graduate program in US, where when I was so used to the metrics system, and now I'm seeing like Pascal and suddenly become water, like inches of water. Like what is that?
Yeah. Haven't you heard grains per pound of humidity? Like grain. The first time I heard that, I was
What
like,
is
what
that?
a grain of? It's a unit of humidity. So like you have pounds per pounds or gram per gram. You have grains per pound. Like a grain is an actual unit.
Oh God,
Yeah.
I haven't heard of it.
Well, that definitely you will use for the desiccant wells heat recovery. Definitely you will see in
Oh.
laboratories.
You can even see like,
You
yeah,
will mess up. You will mess up with your cooling coil. Definitely that you don't want to deal with. But there are like psychrometrics you will mess up with. Sometimes energy model will like break thermodynamics laws. Sometimes energy modeling tools.
So
Okay.
when you get into the construction estimation, you're gonna see a lot of more weird units, like border foot. What is border foot, right? It's a lot of weird units, really. Right? I don't know. Like in the US, I think the units is very messy, and that's why Energy Plus chose metrics. Good call.
Right.
Yeah.
yeah. There's no
I work on-
uniformity. It's
I
yeah. It
work
could
on
go on
internet.
forever.
Sorry.
Sorry, Mukul, go on.
Yeah, sorry about that. I'm having a lag. So yeah, I was saying I work on international projects a lot. So some projects are in Europe and some are in US, and it's not what I look forward to. It's very difficult.
Don't even start about that, because we talk to people like throughout the world. Sometimes it's just Europe, sometimes it's Australia, then they are Japan, and they're just talking about stuff. And if you open the wrong page, like if you have to talk in metric and you open the imperial, then they are like, these are wrong results, we don't understand this unit. I'm like, okay, wait, let me open the other one. So
And I don't
struggles.
understand, like the utility companies, they talk about electricity consumption in kilowatt hour, and like in energy models, we will be using kBTU. I
think
just don't
electric,
understand.
that's like the convention. So anything electric is the load is in watts, and energy, it's always, even in the meter data, it's always like in metric. But when you're talking about heat, it's always BTUs. And even like Energy Plus is actually the only one when you import and when you export in like results in imperial, that's the only one where they display electricity in BTUs, because anywhere else, like it's expected to be in watts and kilowatt hours. So if you're saying BTUs, people will look at you weird if you're like, talking to facilities engineers saying I have like 500 BTUs of electricity, they're going to look at you weird.
It's because different in the IP, different energy uses different units. The
steam.
natural gas is actually used therm, right? The electricity use kilowatt hour, and there's other energy that uses kBTU, like heating energy uses kBTU, but
or steam is actually pounds. That's how it's metered, like pounds.
Right. That's why Energy Plus decided to just use a kBTU to just having one. It's just way too complicated.
I like it, but I still like when I'm writing post-processing scripts, because people are used to seeing it in kilowatts. Now I have to like have that one extra if statement to like convert that one different than the others.
Right.
I hate to be the person to say this, but we are over time and we'll probably end the session now. But it was really amazing to meet you all. Like, I know most of the people here, but Maruti, it was really nice meeting you. Maybe we can have some sessions on those units as well, because we are planning on a number of resources, like starting a building science club where we could discuss all of this, and like a bunch of people can head it. So Maruti, if you are good in something, you can say it. Rashmi, if you are good with something, you can provide your knowledge. And Maruti, are you added to the Slack channel yet?
No.
Okay, so I will check your invite, like the request, and I'll add it to a Slack channel. we have a bunch of other EPSI members there. So we have different groups like jobs and opportunities or learning resources. So feel free to use those channels to talk to people or drop your, stuff.
Yeah.
And I guess all others already know about it. So thank you all for joining in today. And hopefully, we'll see you all again.
Right.
Bye.
I have one question. Do we have any event planned for September, the Symbio?
Not for now. We were planning a job symposium, but it's still in progress, like it's in development. But job symposium needs to have EPSI involved. We will also have to plan career advancement. But if you have any ideas, then drop those in organizing committee, channel.
Okay. Yeah. We'll see.
And Marathi, if you have any questions about the group, feel free to post it on Slack, like asking any channel when you're at it.
Yeah.
Cool.
It was so great meeting you, Marte.
Thank you. See you. Great to meet you all.
Thank you.
Great.
Thank you. Have a
Thank you
good
all.
evening.
Presentation.
Yep. Bye.
Take
Thank
care.
you, everyone.
Bye.
Take care. Bye-bye.